Good afternoon, year nines. The topic for this video is Pythagoras proofs. Okay, so please copy down the title and the date and have a go at the start. So question one, what you need to do is make sure you draw these squares as well. You need to work out the area of these squares. And question two, they've given you the areas and you need to work out the side of the square, or the length of one of the square of each of the squares. Okay, so please pause the video and have a go, please. Okay, let's just quickly go through the answers. So the first one is 4 squared, okay, because length times width, 4 times 4 gives me 16. So the first one is 16 centimeters squared. Remember to write down your units. Next one is 7 squared, 49, 6 squared, 36, 10 squared, 100, 8 squared, 64. Okay, now you've noticed when you're working out the area of the square from question one, we're squaring if we're given one side, all you have to do is square it to work out the area of the square. So what do you think we need to do to work out for question two? You're going to do the opposite, the inverse. We're given an area, we need to work out the length, so we're working backwards. If we were squaring in question one to work out the area, therefore in question two, when we're asked to work out the length, then we're going to need to do the opposite of squaring, which is square root. So square root of 81 is 9 centimeters, so that's the length of that square for question 2a. Question 2b, square root of 25 is 5 centimeters. Question 2c, the square root of 9 is 3 centimeters. And question 2d, the square root of 144 is 12 centimeters, because 12 times 12 is 144 centimeters squared. Okay, so looking at that proof of Pythagoras, what does this guy say? I was born at Samos in Greece. I lived from 580 to 500 BC. I was a mathematician who became famous for discovering something unique about right-angled triangles. Now you're going to try and find out what I discovered. Don't need to know about this person, but let's try and understand what the Pythagoras is about. Okay, so whenever you have a triangle that has a right-angled triangle, okay, this one in particular is a right-angled triangle, and there are squares made up on each of the three sides, okay? What Pythagoras said is the biggest square has the exact same area as the other two squares put together, okay? All right? So what Pythagoras is saying is the small square plus the second smallest square is equal to the bigger square. Okay, so let's work out the area of a square. So the small one would be 3 squared, which is 9, plus the next one would be 4 times 4, or 4 squared, which is 16. And then if you add them up, you should get 25. And is that the area for 5 squared? Yes, it is. Okay, and there you go. That means this triangle here has to be a right angle triangle. This is the proof. Pythagoras proves that a triangle is a right angle triangle if and only if the square of the two smaller sides are equal to the square of the bigger side. Okay, and Pythagoras can be written, the rule, actually in one short equation: a squared plus b squared is equal to c squared, where c is my longer side always, okay? It's also called this word hypotenuse, okay, for the longest side. So make a note of that. The longest side of a right angle triangle is called the hypotenuse. It says here, therefore, the way to show that a triangle is a right angle is to show that the square of the longest side equals the sum of the squares of the two other sides, okay? So for example, okay, pay attention here. The question might give you a triangle like this with lengths 5 centimeters, 12 centimeters, and 13 centimeters. The question could be, is this a right angle? How can I prove this is a right angle? Well, if the sum of the squares of the two shorter sides equal to the square of the longer side, then it is a right angle triangle because it follows the rule of Pythagoras. Okay, so if we square the smaller side, 5 squared is 25, 12 squared is 144, and that is equal to 13 squared, which is 169. So therefore, the sum of the squares of the two shorter sides actually do equal the square of the longer side. And therefore, this triangle here is a right angle triangle. And that's how I prove that a triangle is a right angle triangle. So please make a note of this. So you can rewind, and please make a note of this. Example number 2. Now, I'd like you to pause the video and have a go using the same steps as before. Can you prove that this triangle here, is it a right angle triangle? So use the rule of Pythagoras. Have a go. Pause the video and press play when you're ready to carry on. Okay, so let's work it out. 10 squared is 100, and another 10 squared is 100. 100 plus 100, does it give me 15 squared is 225. 100 plus 100, does it equal to 225? No, it doesn't. Therefore, what does that tell me? This triangle is not a right angle triangle. Okay, so the first step you need to do is just work out the squares. Okay, work out the area of all three squares. If the area of the two smaller squares equal to the area of the bigger square, then that means it's a right angle. In this case here, 100 plus 100 is not equal to 225, and therefore it is not a right angle triangle. Okay, what I'd like you to do now is please pause the video, copy down these questions in your book, and I want you to prove for me whether they are right angle triangles or not a right angle triangle. So please pause the video and press play when you're ready to carry on. Okay, going through the answers now. Question 1, it is a right angle triangle, so these are the answers. And it's because 16 plus 9 gives me 25. Question 2, it is not a right angle triangle, okay, because 10 squared plus 24 squared does not give me 25 squared. Question 3 is a right angle triangle, okay, because 7 squared and 24 squared, if you add them up, gives me 25 squared. You can use your calculator when you got big numbers, okay. You can use your calculator, so use your calculator, okay. And question 4, it is also a right angle triangle because 64 plus 36 is equal to 100. And it mentions here that this question is actually similar to question 1 because they are all square numbers, okay. All right, that's the end of the video. I hope that helps. Thank you for listening.